Here's a situation dealing with electrostatics. So we have a balloon that's rubbed against a cloth, resulting in the transfer of electrons. So let's diagram out what we have. Here is our cloth, and we're going to rub this against a balloon. And we're going to transfer electrons from the balloon to the cloth. So then my electrons are going to go in that direction, which means that my cloth will have extra electrons and my balloon will be lacking some electrons. So that gives the balloon a net charge of a positive 4.05 microcoulombs. That would mean that the cloth would have a negative 4.05 because that's related to the quantity of electrons that were transferred. Now the balloon is brought to a position 5 centimeters away from a styrofoam ball. So then we have another object. Styrofoam ball. And the styrofoam ball has a net charge of negative 2.2. And it is 5 centimeters away. So then in part A, we want to calculate the number of electrons added or removed from one of the objects. Well, I'm just going to choose the balloon. So then our charge of the balloon, 4.05 microcoulombs, and we want to convert this into electrons. First thing I'm going to do is remove the micro symbol and put what it represents. Micro stands for 10 to the negative 6. So this is 4.05 times 10 to the negative 6 coulombs. Now we can convert from coulombs into electrons. One electron has a charge of 1.6 times 10, I'm going to have to move our unit there, to the negative 19th coulombs. So if we divide, we will convert into electrons. So that gives us a number of electrons, 2.53 times 10 to the 13th electrons. Now, we know those electrons went from the balloon to the cloth, and so those electrons would have been removed from the balloon. Part B, calculate the electrostatic force acting on the balloon and the styrofoam. So the balloon is positive, the styrofoam ball is negative. They will mutually attract each other. So then in part B, if we calculate the force, applying Coulomb's law, that's K Q1 Q2 divided by R squared. K, that's your constant, 9 times 10 to the 9th Newton meter squared per Coulomb squared. Multiplied then by each of the individual Q's. I'm not going to plug the sign in. I'm going to use the signs to be able to determine the direction of the force. So 4.05 times 10 to the negative 6 coulombs, converting our micro into coulombs, and 2.2 times 10 to the negative 6 coulombs, divided by our distance, converted into meters, 0.05 meters squared. That's going to give us a force of 32.08 newtons. As we said when we started, one's positive, one's negative, opposite charges attract each other. So there is no positive or negative sign on our final answer, but there is a vector direction of the force as to whether they are like signs or opposite signs, whether they attract or repel. Part C, calculate the electric field strength at the location of the styrofoam ball due to the balloon. So then we want to know what the field is right here. at the location of the styrofoam ball. E is equal to force over charge. That's one of the ways that we can calculate it. So this is the force on the object divided by the charge of the same object. So then our object would be the styrofoam ball. So the force acting on the styrofoam ball, 32.08 newtons. And the charge of the styrofoam ball, 2.2 microcoulombs, or 2.2 times 10 to the negative 6 coulombs. That's going to give us 1.46 times 10 to the 7th newtons per coulomb. Now, in terms of a direction, we denote the direction of an electric field in the direction a positive test charge would experience a force. So we are going to imagine a positive charge at the location of the styrofoam ball. A positive charge here would be repelled away from the positive balloon, and so our direction would be away from the balloon. Ponder physics.